What we're going to do is factor cubics, and there's a special factoring pattern. There's the sum of cubes and the difference of cubes. The sum of cubes is when we're adding two numbers that are cubes, and the difference of cubes is when we're subtracting two numbers that are cubes. How the formula works is we take whatever the numbers are and we write them to the cube root. Sorry, to the cube, not the cube root. And our a value substitutes into our a and our b into b. So with the sum of cubes, we add a plus b, we square a, we multiply a and b, and we subtract it, and then we square b. Notice that the difference of cubes is almost an identical formula, except we're subtracting a and b, and then in the middle here, we add the product of a and b. So for example one, first thing that we're going to do is we're going to write it in the form of the difference of cubes. So x cubed is already written as a cube. 27, we're going to write it as 3 cubed. So that means that our a value is x and our b value is 3. So when we plug it in, we have x minus 3 times x squared plus 3x plus 9. Now, just to show you how this works, we don't have to do this each time, but just so that you can see that this factoring pattern works, if we FOIL it, which is the opposite operation of factoring, x times x squared is x cubed, x times 3x is 3x squared, x times 9 is 9x. Negative 3 times x squared is negative 3x squared. Negative 3 times 3x is negative 9x. And negative 3 times 9 is negative 27. Notice that the 3x squareds cancel, the 9x's cancel. We're left with x cubed minus 27. So we can see that that's our original problem. And that shows us that the formula actually works. So looking at letter B, we're going to do the same thing. We're going to write it in the cube form. So this would be 2x cubed, and we would have 5y cubed. So our a value is 2x, and our b value is 5y. So our answer is 2x plus 5y, 4x squared. When we square the 2x, that's what we get, minus 2x times 5y is 10xy. And then when we square 5y, that gives us 25y squared. Looking at letter C, this is a cubic, but it's a little bit different. Notice it has 4 terms. Whenever it has 4 terms, we factor it by grouping. We factor the first two. They have an x squared in common, and what's left over is an x minus 3. Then the second two, they have a negative 4 in common, and that gives us an x minus 3. We notice that they both have an x minus 3 in common, so we factor that out, and we're left with x squared minus 4. Now the x squared minus 4 is a special factoring pattern that factors as x minus 2 and x plus 2. Let's look at some more problems. With the letter D, if we write it in cube form, that would be x cubed plus 2 cubed. Our a value is x, our b value is 2. So we write it as x plus 2, x squared, because we square the a, minus 2x when we multiply a and b. And then when we square b, we get 4. Letter E is a little tricky because they don't have cubes, but we see that they're both even. So we first factor out a 2, and that gives us 125x cubed plus 1. And then we see that they are cubes. This would be 5x cubed plus 1 cubed. So our a value is 5x, our b value is 1. When we write this, we're going to keep the 2 in the front. We have 5x plus 1. Then we square it, 25x squared minus 5x plus 1. For our last one, notice that we have 4 terms, so we're going to factor it by grouping. We're going to factor out an x squared, and that gives us x minus 5. Then we factor out a negative 9, and that gives us x minus 5. So we're left with an x minus 5 and an x squared minus 9. X squared minus 9 is a special factoring pattern. It's a difference of squares, so we write it as x minus 3 and x plus 3.